third, fourth, all the way up to 15 survive. So here with this one, we're looking at the probability that all 15 survive. It's just going to be the probability that a given one is going to survive raised to the power of 15. It's just going to be kind of small, I think. Right. 9, 10, 8, 6. So we get 0.8846. Okay, so that's not actually what they're asking us. I probably should back up a little bit and talk about what I'm doing. Sorry about that, that's not what I want. Go back here. Okay, so that's the probability that all 15 survive, but they're saying, what is the probability that at least one will die during the course of the year? So with this one, so if we go back and think about our options for what we could do to figure out this one, they're saying at least one. So one is the least number of people that can die out of those 15. So either one could die, or 2, or 3, or 4, or 5, or 6, or 7, all the way up to all of them dying. So that's our possibility. And so since those are mutually exclusive, you could technically find those probabilities individually and then add them together because they're ORs. But that's going to get a little bit complicated. So what we're going to do instead is we're going to use the rule of complements. Anytime they ask you for at least with probabilities, you're going to use the rule of complements always. In chapter 5 and in chapter 6, that's what we're going to do. So whenever you see at least probabilities, we're always going to use the rule of complements. Okay, so if our event E is that at least one dies, like I said, that's going to be, 1 is the least number of people that could possibly die. So it could be 1, 2, 3, 4, all the way up to 15. So E could be 1 dies, 2 die, 3 die, all the way up to 15 of them die. So that's our event E. But like I said, we're going to use the rule of complement. So this is our event E. What would E complement be? So what options do we have that are not included here?
None of them died.
Yeah, none of them die. So if we're looking at how many of them die, these are 15 all the way up to 1. The one that we're not including is 0. What happens if 0 of them die? So if 0 of them die, that's the same thing as saying that all of them survive. That's another tricky thing on this one. A lot of people forget about 0 being a possibility. So if they look at the event E, at least one of them dies, they've got all the numbers listed from 1 to 15, but they're leaving out 0 because there's a possibility that 0 people die. So don't forget about 0 as an option for these ones. So if we want to find the probability of E where at least 1 dies, probability of E, that's going to be 1 minus the probability of E complement. So 1 minus the probability that all of them survive, which we found up here, a little prematurely, apologize about that. But this one we already found to be 0.8846. So if we subtract those out, we get 0.1154.
Yes,
99, 910?
Yes,
Sorry. Okay, awesome. All right, so the probability that at least one of these 15 people survive, sorry, at least one of these 15 people dies is going to be about 11.5%. So that's how you'll use those ones with the rule of complements. And we're going to be doing that a lot more in chapter 6 in section 6.2. These at least probabilities, they come up a lot in section 6.2. So, but whenever you see this phrase at least when you're doing probabilities, you're going to want to use the rule of complements for that one. Set it up. Okay, so now we've got our summaries listed at the bottom. So if you're looking at probabilities, if they ask you what's the probability, it should be in between 0 and 1. If you're getting something in your calculator that's like 26.8, just go back and redo things because it shouldn't be anything higher than a 1. It's going to be in between 0 and 1, and again, we're going to use decimals for these ones, not percents, just because, like I said, with these ones, you'd get something really wacky if you tried to do 99.186 to the 15th. This would be a really, really big number. So just keep in mind you want to change them to decimals first. If you look at all the different outcomes and add up their probabilities, it should equal 1. If you're constructing the probability distribution yourself using the empirical method, it might come out to something like a 0.999, and that's okay, and that's just because of rounding. It's not a big deal, but it should be pretty close to 1. If you're coming up with it on your own, it might be off by a little bit just because of rounding, and that's not a problem. We have the addition rule. Whenever you see or is going to change into a plus. We've got this rule for complements. Just take the probability of the event, subtract it from 1 to get the probability of the complement. And we're going to use those most often when we see these at least probabilities, these problems like this up here. And then lastly, if we have the multiplication rule, anytime you see and is going to turn into multiplication.